for that there is a so the gradient you are getting is at what stage, like after the ReLU one? Sorry, I could not really. Before the ReLU. And there's a convolution happening. Which is the output. So with respect to that convolution weights, you have to get the gradients. Is that? So actually, the gradient with respect to those weights will so
एक मैं हेलो बोल रहा हूँ 11 लोकेशन में किसी है ग्रेडियंट है 11 लोकेशन में लोकेशन 11 पे जब बैक प्रोपगेशन कर रहे हैं तो वैल्यू ऑफ द ग्रेडियंट कितने हो रहे हैं 3 हाउ द वैल्यू आई एम नॉट अंडरस्टैंडिंग answer has already been uploaded here, but how it is done is not done.
See, the back propagation in convolution is different from standard back propagation. Yeah.
There must be a very small problem. So this one is one. Just I need to know the problem, and I will come only one location gradient, and I can come all. Just the problem.
It will turn out to be a convolution of your gradient and the weight matrix. I think. Sorry, I can't recollect it properly.
Can it present the screen?
Yes, yes, you can. Yes. The feature not given below is the output of a convolution rate. I am not sure of how guided back propagation works actually. I'll have to check with that and let you know.
Ma'am, how it is also this is a problem solving session, and in the week 7 also so many problems are there, right? Because if I cannot solve week 6, then how can I solve week 7? And the problem you will get in week 7 also. Should I show you?
Of course they are there, I'm not denying that.
So ma'am, how they solve? First, I can do the week.
See, what happened every week, many people are not going through the lectures by the time they are attending problem solving session. Every time I ask how many of you have gone through the lectures, it turns out barely any of you have gone through. So which is why I look at we are going through over the concepts actually. So that is what I suggested for people to go through the lectures so that we can actually discuss problems in this.
Ma'am, I have gone through the lectures, so the 50 questions ये मुझे तो देखिए 3 marks.
Yeah, I know, I'm not denying it.
आप मुझे बिल्कुल समझ नहीं आ रहा मैं क्या करूँ बताओ आप आपको 30 दिन का भी एग्जाम हो.
Yeah.
Ma'am, how otherwise you can do one. You can ask other people also. So many students are getting advantages. Ask if they can solve it.
I can check about this and I'll let you know.
Ma'am, एक one more one. एक और नीचे जा रहे actually ये question can
So here you have a zero image, right? Zero image, and they have given the gradient of the loss with respect to the input image. So you are updating the image with a learning rate of eta given as 5. So it's like you are doing my x at t plus 1 is x at t minus eta into dou L by dou x. So dou L. So this is
ma'am, please solve this question. I think you can solve.
isn't it's so that gradient into the learning rate.
Yeah, again, this is a learning rate. Okay. So ma'am, can you please solve?
So eta is 5, right? So at location 1, 5 into 0.2 is 1. Can you go down? Location 1 comma 2. At location 1 comma 2, it will be 5 into 1. So okay, I don't see. X at time instant t plus 1 is equal to x at time instant t, which is given as a 0 image to you, right? So that is a 0 image, it's given. Suppose the image is 0 plus it is gradient ascent. That means you are doing plus eta, the learning rate, into dou L by dou x. So that is the matrix that they have given, the 3 cross 3, right? So what your x at t plus 1 is actually eta into that gradient matrix, because your initial image is 0. So it is basically this gradient multiplied by 5. This matrix multiplied by learning rate, right? Eta into dou L by dou x is the how much step, like learning rate eta into what direction. So the direction is given by that matrix here. So you just have to multiply it with 5. So that will be the new image. 5 is 1, 5 into 1 is 5,
1.4 into 5, 7. Fine.
right?
Yes.
Assume that the feature map given below is generated from a convolution layer in CNN, after which a 1 cross 2 max pooling layer 1 cross 2 with a stride 2 in horizontal direction and a stride 1 in vertical direction is applied during this is a max pooling layer. Okay, during back propagation we get the following gradient for the pooling layer. Okay, assign the appropriate gradient value for the locations in the feature map. So see, in max pool, okay, so this is a 1 cross 2 pooling, right? That means if I take the 1 cross 2, so the top 1 cross 2 matrix, that is 50 and 10, right? If I max pool, I'll get 50, correct? Out of, so 50 and 10 I am max pooling using 1 cross 2 filter, like so I'll get 50, right?
So why 1 cross 2?
One, it's 1 cross 2 and stride is 1, so you will get 50, and then if you move it by one location, can you go up? It is stride 2 in horizontal direction, so stride 2 100 and 200, so I'll get 200, right? And stride 1 in vertical, so basically same thing, 40 and 90 say I am picking 90, and 60 and 80 I am picking 80, correct? So that is my
50, 200, 90,
90, 80, that is the output of max pool layer here. And during back propagation, so basically I have 4 values now. So with respect to those 4 values, this gradient is given 10, 20, 30, 40. Now this gradient, these 4 values I have to expand to that 2 cross 8 matrix, right, to the input. I assign the appropriate gradient for the locations at feature map. So that 2 cross 2 feature map I have to get the gradients. So in max pool, because see I am picking only the value 50, right, in my forward pass, so the 10 value is not even being picked up. So when I back propagate the gradient, that gradient will go back only to that location. So so this 10 will basically go to that to 1 1 location, and 20 will go to the location of 200 1, 4, 30 will go to the 90th location, 40 will go to the 80th location 2, 4, other classes will be 0. So that will be the grade. In the remaining locations the gradient will be 0. What? That's all, right? Location at 1 1 will be 10, no, because 10 is going to 50. Location at 1 2 will be 0 because 10 was not picked up earlier, so no gradient will pass. 100 also is 0. So 200, 20 will go to 200 because it, yeah, like that.
Like that. And this is one more. 20. Fine.
So that locations have to be remembered in max pool in forward pass. So gradients will propagate only through that direction, others will be 0 because it didn't go in the forward pass, right? So it will not contribute to loss, I mean in the backward direction.
Now one more thing, for the same previous question, use the average.
Use the average pooling, yeah, okay. So in average pooling, because when I forward pass, I would have done 50 plus 10 by 2, right, to get the value.
50 plus 10 by 2.
50 plus, so that is average pooling function, 50 plus 10 by 2.
Then side of
100 plus 200 by 2. So when I pass the gradient back, that gradient will contribute to both the positions, 50 and 10. So it will get, so 10 will go to both locations, the 1 cross 1 and 1, 2 also.
Because I think we go to the 50 plus 10 by 2.
Huh.
The values are 30%. The 10 will go to 50 also, 10 will
Go to 10 also, yes. In max, here all gradients will pass through all the feature locations. In max pool, it doesn't.
100 plus 200, 100 by 250. When I go 1 3 maybe 20 जाएगा, 1 4 maybe 20.
Yeah.
So fine.
30 goes to both 40 and 90 location, like that.
Okay, one more.
Okay, in the last convolution layer of a CNN, okay, during backpropagation, gradient of each activation map is given by that. Okay, using gradcam method, compute the attribution map for cat class, considering the normalizing factor z equal to 4. Wait, go, can you go up? So, so what, wait, anything more above than this? Cat,
phi equal to cat.
y equal to cat, but go up, scroll more. That is where the question starts. Where, what is that where the question starts?
Yeah, yeah. Following other activities. It starts from here.
No, go up. Is there more? What is? Nothing is. No, I'm like.
नहीं मैम, it's not मैम, please take your time. It happens. But you can talk. I understand that you have a lot of.
No, I'm also a student, like just like you guys. By the way.
We take our time. I have seen at least.
During so the gradient so here we have if you
There equal to by writing the data. Y equal to cat. And 4 2 activity methods.
see, to compute the activation maps, these are the two things only you need. So it will be a so the so basically it's like it should be a linear combination of the activation map 1 and 2.
How can I combine it, ma'am? It's 120 minus 270
Linearly, but I need to determine the weights. That weights are determined by this gradients given. So that like the weight for the activation map would be average pulled output of this gradient. So if you see the gradcam formula, gradcam, so it's a linear combination of, so basically activation map 1 into some alpha 1 plus activation map 2 into alpha 2 into alpha 1 plus activation map into some alpha 2. That so that alphas are determined by these gradients which are given. So that alpha turns out to be the average pull output of this gradient activation, I mean the below this. So alpha is average of this basically 0.1 plus 0.2 plus 0.3 plus 0.4 by 4.
plus 0.3 plus 0.4 upon 4.
Yeah.
1 by 4 means 0.25.
Okay, whatever. So
ठीक है.
that
10 1.2 by 4. 1.1 by 0.2. Alpha is 0.2. Now can I multiply as this?
you can multiply and sum them up. That will be your grad cam output, and you can
120 into 0.2. Okay. But 120 is the whole activity now, right?
whole.
Let's give me one only the two. Okay, I'm doing 50 plus 0.3 into 70, 10, 50, 100. Okay. So 120 into 0.25, 35, 37, 130. Ma'am, how 0.1 location to get some 1 location how to do it?
You will get a 4x4 map, right, if you do that.
Okay, that's right. 30, yeah, minus 5, 5, 4, 25, 0.5, and one is 4 to 3. ठीक है, एक ये देखिए प्लस 70 21, and this will be 33, 53 to 150, 15, and one is last is 100, 0.3 into 100, 300 30. ठीक है, so 21 plus 30, 51 should be the first, 1152, fine, it's got it, I got it.
Yeah, so this was there in the grad, so you just had to apply that formula from grad cam.
Get the source. And what to do is this, please look into it. Next time can I ask this question?
Yeah, sure. Like, I see, given that you people have watched the lectures, we can discuss the problems. That is what I did in my first session actually. But if people have not watched the lecture, I cannot discuss the problems, right? Do you understand why I was not discussing problem? How do I discuss a problem if people have not watched the lecture? You don't know the content, how can I discuss problems straight away? So if I ask, so that I actually requested people to watch the lectures, because if you watch lecture, then I can prepare problems and discuss problems. If that doesn't happen, I can't just jump into problems. Like, so I'll revisit whatever content is there, so that at least one topic we'll discuss in detail here. So that's what was happening. That's why the first thing I ask is how many of you have watched the lecture, and not even, I barely hear a yes. So how can I even discuss problems? You tell. That's what happened.
जैसे आज आप कराओगे ये क्विट 7, ठीक है, डाउट, ठीक है, so we can Manoj ma'am, can I give you suggest you something if you forget to do I can suggest you.
Yeah, sure.
What I'm saying, that means suppose you are discussing the lecture, so fine, but last time also you discussed, I was very okay, but when I was submitting the question, I couldn't get it. I'm telling you fact. So why couldn't you do that previous year service previous? Okay, I'm not talking about just
Sure. I'm not denying that. Problems are fine. We'll design problems to discuss. That was not my problem. Problem was people have. You should have watched lecture before coming to this problem session. That's all I said.
Why did you do one thing? हम क्या करते हैं? Problem से हम concept में करते हैं. Exactly this issue में हम problem solve कर पाएंगे. Concept clear है.
ठीक है, कर सकते हैं.
हाँ, let's start with the previous year paper. Question number 1. Previous year. Seventh question is very easy, sir.
You just have to apply that filter on that image to get the output and match them.
Yeah, 6 plus 1 minus 4 plus 2, it will be 1. The first. No, 6 plus 1, because it's going to cover the complete 1 and 6. 1 is going to cover the 1 and 6. So it will be treated as the white part. And 2 and 4 will be treated as the black part. So we have to add the white part and black part, and we have to find the minus of both these. So 6 plus 1 minus 4 plus 2 will be equal to 1. So first, second, so first, second answer will be there. Similarly, for second, the third answer will be there. For third, first answer will be there, and the fourth will be the fourth answer. You have to just cover. You have to just cover the values.
Basically, wherever 1 is there, you add them, zeros are there, minus them.
Wherever 1 is there, add them.
Yeah.
What I have to add them? 6 and 1, because 1 is going to cover the 1 and 6.
So, see that 1100 is like a pattern, like it's an edge, right? Like it's a step thing. So, treat 11 as 1 and 00 as minus 1. So, you are extracting a feature there that will detect an edge.
0 and minus 1.
6 plus 1, so treat zeros as minus 1 and it's like filtering.
अच्छा माने 1 plus 6 और एक होगा 4 minus 4 because minus 1 ना 0 0 है.
Yeah.
4 minus 3 is 2 और 6 plus 1 is 7. So 7 plus 3 is 3.5 है ना. After 6 is 7 and 4 and 2 also has to be added. So it will become 6. 7 minus 6 becomes 1.
4 plus 2 minus 6 minus 1.
4 plus 2 becomes 6 and in the other side 6 plus 1 becomes 7.
So it is 6 minus 7, minus 1.
Yeah.
Yes.
Then what? 6 plus 1, 4 plus 2, 6. 6 plus 1 is 7 and 4 plus 2 is 6. So 7 minus 6 is 1.
Minus. No, it is the other way, no? 0 0 1 1 means 6 minus 7.
Yeah, other way it will be minus. Ma'am, yeah, आप इसको properly explain कर सकते हैं. Like the way you explain now.
Okay. Okay. See, here wherever zeros are there, replace them with minus 1 minus 1. Okay. Like it's just how they are representing it. 1 1 0 0. You can write them as 1 1 minus 1 minus 1. Okay. And minus 1 minus 1, and treat that as filter. Multiply element wise to your
Filter.
So
Multiply the element 1 6 2 4 that.
yeah, so that's all it is. So see in say in the
1 to 1 plus 2 plus 6 minus 1 minus 2 और ये हो गया 6 plus 4 और minus 6 minus 4. ठीक है, ये हो गया 3 7 minus 3 minus 1. ये तो आ गया सर मैं 3 7 minus 3 minus 1.
no. See in the second case 0 you have 0 1 0 1, right? I mean, so what is it? 1 6 go up.
1 6 up to 4.
So it is go up. See, it is 1 into 1 minus 1 into 2 plus 1 into 6 minus 1 into 4.
1 into
1 minus 1 into 2
minus 1 into 2
plus 1 into 6
1 into 6
minus 1 into 4.
minus 1 into 4. अच्छा 1 minus 2 plus 6 minus 4. So 6 minus 4 is 2. So with 1 is the answer. So how is it different?
See, you mask that whatever like those har features 1010 over your image. It's like put this over that, multiply them. Instead of zeros, treat them as minus ones.
अच्छा ओके अंडरस्टूड 1 1 minus 1 minus 1 उसको ऊपर चढ़ा दो
हाँ
सीधा ठीक है 1 into 1 minus 1 into 2 1 into 6 minus 1 into 6.
Yeah.
अच्छा समझ आ गया, ये हो गया, clear. अब ये वाला the integral part of the image.
The integral part of image is, so starting from that, so at any location the output of the integral image is sum of all the values until that point, like say
Yeah, what where it means check 1 second, I will write.
see the output of integral image say at a location xy is equal to summation over I is equal to 0 until x, j is equal to 0, j is equal to 0 until y,
J equal to 0 until y.
I of xy, like the image
X I y.
I mean I of I and j,
I of
I comma j,
I comma.
like in this case say for 4 I have to compute, that means I have to sum 1 and 4,
For 4 and for 1 and 4.
1 and 4. For 2 I have to compute means I should sum 1, 5, 4 and 2, basically the upper corners until that point.
Okay.
So
8 का करना है तो फिर क्या होगा 4 to 159.
yeah, 4 to 8 159 all of them.
हाँ, सब नहीं, suppose 8 के लिए मुझे करना है 8.
हाँ, so 1, 5, 9, 4, 2 and 8.
Now 8 क्यों होगा फिर 8 को भी करेंगे.
हाँ करेंगे.
Suppose मैं 7 के लिए कर दूँ.
7 के लिए it will be 1, 5, 4, 2, 6, 7.
1, 5, 4, 2, 6, 7. अच्छा, upper corner.
Upper corner until that point along both directions.
Now it is a rectangular. I cannot say that it is corner.
It's not corner, I mean x and y until that point, sum all of them.
Suppose I take 3, तो हमें पूरा लेना पड़ेगा, पूरा मैट्रिक्स को लेना पड़ेगा, ऐड करना.
Yes, it will turn out to be the second one, you can check for a value.
जैसे 3 सारे ऐड करो तो 45 आएगा. 9 5 15 ना. 9 5 4 15, 8 4 10, 8 4 12 14, 28, 3 32, 7 13. हाँ ठीक है, फाइन, समझ आ गया. अब एक क्वेश्चन 9th वाला. मैम एक क्वेश्चन. Roy or average pulling for extreme.
See, average pooling is that you know, right? Like whatever my filter size is, I just average all of them. That's all average pooling is. So, what is ROI average pooling? It is used in object detectors, region of interest average pooling. Ha. So what is ROI pooling? Someone explain it to me. Let me see. Anyone? So, see, note that the output size after applying ROI average pooling is 2x2. So, basically my region of interest is 4x2, that is given. From this, I have to get a 2x2 output. 2x2 output, right? So, that 2x2
Man, is it a must that always average pulling will give the size 2x2?
no, it's not that.
Can it be good?
No, it can't.
Right, note that the output size after applying ROI is 2x2, give it like that, okay? Suppose the size of the image is used, engineering is very used, not 4x2. Suppose 400 plus 400, then
See, given any object size, ROI pooling is used to bring it down to a fixed size. Here they have said it to be 2x2. Say it is some 10 cross 10 object, and but my pooling output is fixed to say 3 cross 3. Okay, that from 10 cross to 10 I have to get a 3 cross 3 output.
You have to get out.
So 10 cross 10 to 3 cross 3, how will I divide and average so that I can get a 3 cross 3 output? So that is what ROI pool. So in this case, if I have to, sorry, so in this case, if I have to get a 2 cross 2 output, basically whatever input is there, I will divide them into 2 cross 2 blocks. Okay. So here if I have to divide them into 2 cross 2 blocks, how will it happen? 2 rows belong to one block, like that, right? 1 comma 2 belongs to one block, 4 comma 3 belongs to one block, 1 comma 5 belongs to one block, 3 cross 2 belongs to one block. So basically you should put a 2 cross 2 grid over that region of interest, and whichever falls into whichever group, you average pool over them. So it will be 1 plus 2 by 2, 4 plus 3 by 2, 1 plus 5 by 2, 3 by 2, 3 plus 2 by 2. 1 plus 2 by 2, that is 1.5. 4 plus 3 by 2, 7 by 2 is 3.5.
Okay,
it's like, given your region of interest, I will divide them into 2 cross 2 blocks. So if I have to divide them into 2 cross 2 blocks, that is how I will divide them, right? Here I will put 1 and 2 together, 4 and 3 together, 1 and 5 together, 3 and 2 together.
Then I am getting them rows and columns. 3 rows, 2 columns I am getting.
How 3 rows? 2 rows. 1 and 2. 1 and 2 is one group. 1 and 2 is one group. 1 and 5 is one other group. It's like you should make a grid of 2 cross 2 over that. How will you make? You just have to put one separation horizontally, vertically. Halfway you will divide it, right? Halfway division is that.
समझ आ गया आगे ना clear है.
Just in Japan, from where we can get this question?
I have got Google.
Can you please share it in the link?
I will share.
Just share it in the chat so that we can also see.
Okay. I'm sharing, ma'am. Ma'am, can you send me the bill?
So you have to compute
एक्सप्लेन करना पड़ेगा. What are ion stone? थोड़ा सा इससे भी कॉन्सेप्ट क्लियर हो जाएगा. What is ion stone?
it's called intersection over union.
Intersection over union. What is this, ma'am? Clearly.
Wait, it's easily explained visually. If you have two bounding boxes and representing size of region cross 3. I will have to See, if the size of, they've given the size of the blocks 2 cross 2, 2 cross 3 and 2 cross 1.
So,
So IOU score is intersection over union. So the overlapping area between both the regions is the third region, 2 cross 1 is what they've given. So the size of that region divided by union of all of them. So it will be 2 divided by union of the entire region will be 2 cross. You know, you will have to write this out, right?
मैम एक एक sort of front है, फिर आप अपना शेयर करके किसी बता दो. This was the last.
Cross 3 and okay, can you unshare your screen? I'll try to type this out as I go.
What did I do then?
Unshare your screen. I'll share my screen.
Okay. Please.
So suppose I have to compute IOU. They have given region. Can you see my screen?
I can take it.
Okay. So R2 is this and overlapping region is this, right? So each of these are actually boxes. Like if I so yeah, so it's like, say this is my region 1, the first one, this is my region 2, okay, and this is, first one is 2 cross 2 size, okay. So this is 2 cross 2 and say this is 2 cross 3, say this is, I mean, so these are 2 blocks, right, 2 cross 2 size and 2 cross 3 size. Now they have said the overlapping region is 2 cross 1. So how should these two be present if the overlapping region is 2 cross 1? Like it's, see, somewhere I can overlap in anywhere, right, like this way. How, what way of overlapping will result in 2 cross 1 region? Okay, say currently I put it as these 2 blocks. Here what is the size of the overlapping region in this case?
Here,
1 cross 1, right?
how much?
So which is the overlapping region? This part, right here where I am pointing. What is the area of that? 1 unit, right? 1 unit. 1 unit. So that's the overlapping region. If I make it like this, so now what is the overlapping region?
This is
2 comma 2 cross 1. 2 cross 1. So for 2 cross 1 to be overlapping region, it should be like this, right? Understood? Huh? Does that make sense? Here this size is 2 cross 1, right? Overlapping region. So this is how these blocks are for the given specifications, 2 cross 2, 2 cross 3, 2 cross 1. This way or this way, one of the two, both are the same. So here if I have to compute intersection over union, so IOU is intersection area by union area. So my intersection area here is 2 cross 1, right? So 2 units is the intersection. So what is the union? That's the entire union of the both regions. So how many units are there? Union. 2 cross 3 is just the second block. Union of both.
So 3 are equal to 2 cross 1.
There are 6. Anyone? What is the union?
Ma'am, R1 plus R2, the union says 10 on max, sir.
How 10?
2 cross 2
See, if I keep it like this, one next to the other, that time the union will be 10. If I keep it like this, union is not 10. 8. This has 6 units plus 2 units here. So the union is 8, right?
And the row you have overlapping this is just now, it is 1 cross 2, not 2 cross 1.
This is
1 cross
this is 1 cross 2. This will be 2 cross 1. Yeah, correct. Yeah, so this is 2 cross 1. Either way. Now, so what is so either overlapping region is still 2 cross 1. So the size is 2 units. Union of both. So now what is the union of both regions? 8, right? Array area of this region.
plus 3. अच्छा दोनों से ऐड करो सर,
Add नहीं.
मल्टीप्लाई कर रहे हो तो ये रेड रीजन को
See, red region is 6, right? Red region is 6. And what is the grey region present here? 2 units, no? 6 plus 2 is 8.
हाँ
So union is the area covering both of them. The common, I mean, how do I explain? If it is sum of areas are different. No, sum of area, if it's like this, then the union will be 8 because they are disjoint, right? I mean, it's not 8, 10. 10. This is 4, this plus, I mean, the union of these two because they are disjoint is 8.
why they different? Why you doing different?
There is no overlapping region between both of them, no, they both are disjoint.
आपने पहले तो 2 cross 1
Array, I am trying to explain how you are computing union, that's all.
okay.
In this case, it is 8, right? Union of both. So 2 by 8 is the IOU.
अच्छा 2 by 8.
So it will be 0.25. So basically, for the given configurations like R1, R2, and overlapping region, you should see how do you place the two blocks such that the overlapping region is what is given. In this case, I can place it this way, right? Or this.
एक और क्वेश्चन है 2 cross 2 4 cross 1 2 cross
4 cross 1 and 2 cross 1. So okay, I have 1 2 cross 2 and then say 4 cross 1 will 4 cross 1 will be something like this, right? Now overlapping region is 2 cross 1. So how can I overlap these two? Hmm?
You put it exactly on the first row or second row and
हाँ ये क्यों हो जाएगा
This way, right? This way or this way, that's all. I mean, so now what is the intersection region?
2 cross 1
2 cross 1 only, so it is 2. And union?
union is 2 plus 2 into 1 4 union is 4
How 4?
ऊपर का प्लेन नीचे का प्लेन 2 into 1 कितना ठीक है
नीचे का पूरा लेना है.
हाँ 2 into 1 हो गया
2 नहीं 4
अच्छा 4 into 1 4 हो गया नीचे का
and the above part is 2.
तो 2 into 1
So 6. 6. So IO is 1 by 3.
1 by 3 0.6 एक और part लेंगे और क्लियर हो जाएगा लास्ट 2 cross 3
2 cross 3,
2 cross 3
2 cross 3, 2 cross 2. 2. So say 2 cross 3. This is 2 cross 3. Fine. Region 2 is also 2 cross 3. So I'll make this short. And
Ma'am, R1 is 6, ma'am. R plus R2 is 6. Total 12, ma'am. Minus 4 is 8.
the union, yeah, that's all right. Yeah.
4 by 8. So 1 by 8. 5.
Yeah, yeah, that's all it is. Union is area of R1 plus area of R2 minus intersection region. So union is area of R1 plus area of R2 minus the overlapping region.
8.
Yeah.
So 4 by 8. 0.5.
Yeah. You should know the answer. You check there. Same thing, right?
So then, count.
What is the 4?
Answer then, what is 4? 0.5. Answer is 0.5.
Huh, 4 by 8, correct? No.
Answer 4 by 8. ठीक है, fine.
So how will the overlapping region, this is also to get, I'm showing these boxes so that you get an idea of how objects, not just computing your answer. Like basically what these are corresponding to two different objects, and I want to compute IOU. That is what is happening. So if you have to get a 2 cross 2 intersection, it will be something like this, right? Okay, wait, this way. Yeah, sorry.
ये पूरा जाएगा.
Like this. This is 2 cross 2, no? The overlapping region.
ठीक है मैम, ये 2 cross 3. तो इसमें ये निकाल, ये फर्स्ट वाले क्या है, जो ब्लैंक वाले, ये 2 cross 1 है.
हाँ.
That is 2 cross 1.
This is 2 cross 2 and this is 2 cross 1.
हाँ, 2 cross 1, ये 2 cross 1. ये दोनों को ऐड करो, अपन
8 you will get. अरे 2 cross 1 plus 2 cross 2 plus 2 cross 1, 2 plus 4 plus 2 is 8. Yeah, I'm not telling it's easy. I'm not telling. Yeah.
अब आपके पास क्या है, थोड़ा थोड़ा एक्सप्लेन करो. तो आप जो आदित्य से निकला है, थोड़ा शॉर्ट में खत्म हो रहा है. या whatever you got it, वो शेयर कर देना.
I'll continue with this only. So why IOU is used is, so suppose two objects are like this. So like there's some deep learning model that has given you bounding boxes, okay, lots of bounding boxes. So it's all like at the same place, because there's an object there, it can give multiple predictions slightly shifted by each other, okay, like so assume there's an object here and it has given multiple predictions. Also all of these will fit in your object well, right? Like nothing is like totally right or wrong as such. All of them, there's an object there, so you can get multiple boxes like this. So here if you see, there's a dog here, right? Like lots of boxes are there at the same place. So that can happen, right? So just because I shift the box by 1 pixel doesn't mean it's wrong, correct? So in such case, I would want to filter them out. Instead of these 4 boxes here, I want to get only 1 box. That is enough for me. So what they do is, I will compute. I will basically I would have also had some confidence score for each of this box. How confident it says an object is present. So I will take the highest one. Say suppose this red one, right? Red one box, the red box has highest confidence. All of them also have some other like slightly lower values. So I'll take this red box. I'll take this as a reference. I'll compute its IOU with all the other boxes, with the other 3 boxes. And if I see the IOU is very high, that means that intersection over union, say say I use some 0.8 threshold. Okay. If the IOU is greater than 0.8, that means they are highly overlapping, right? It gives a measure of how much the boxes are overlapping. If they are overlapping a lot, then I can remove the other box because it's almost very close. So in this case, for this box and this behind one, the IOU will be very high. In that case, what I will do is I will remove the other one because it's noisy, right? I need only one. I will filter the boxes, so I will remove that. Now suppose this one is somewhere here. Okay. In this case, the IOU will be very less. Say here, suppose this is just one unit IOU here. Okay. Like only one unit is overlapping. So the IOU will be very less here, right? My union is way larger than this.
So I will less different, then I will right?
So wait. So in this case, what will be the IOU? Now you tell me. Only one unit I have overlapped. What will the IOU be here?
What is it? 1 cross 1. What?
IOU.
IOU. Intersection upon union.
Huh.
So 1 upon
1 upon
1 upon 2 cross 2 है ना?
2 cross 3. Both are 2 cross 3.
2 cross 3, 2 cross 3. 1 is 6 plus 6 minus 1.
Hmm.
5.
Hmm.
1 by 5.
Hmm.
1 by 5.
Hmm.
0.2.
0.2. So IOU is very less, no? IOU is very less. That means it is probably a different object because it is not overlapping significantly. So I will keep this.
मैम ये जो है elliptical of box
Hmm.
fixed right दोनों दो
IOU is 0, no?
IOU 0 हो जाएंगे
IOU is 0. So I will keep that. If it is very overlapping, if it's like this, okay. In this case, because it's overlapping, a very high IOU will be there. So I will remove this. Remove it. If it is far, like it's not overlapping much, then I'll keep them because it's probably separate. If it's overlapping a lot, if
overlap suppose 2 boxes are overlap okay fine okay ma'am then if the IOU is very high that with both the boxes then I can keep any one of the boxes
that is what, yeah, that's what we are doing. If it's very high, I will remove the other ones. If it is low, that means it is separate object, no, something else is there, so I will keep them. So IOU is used to filter boxes. Like if I have my prediction gives something like this, like lots of boxes are there, now I want to filter them. I do this, this is called non-maximal suppression. After doing this, I will get only one box. All these repeated boxes which are slightly shifted versions, no, all those I will eliminate them. So that is why IOU is used in object detection.
okay very nice very good so yes
Okay then.
Manoj ma'am I got tired today
No, like this was not in the plan, that's all. But it's fine.
what I need to ask you that जैसे आज आप डिस्कशन का क्लास हो गया ठीक है इसमें प्रॉब्लम नहीं है तो नेक्स्ट क्लास में भी also one more class no problem
Yeah. Next, yeah, every week it will be there, no?
No, there are two. Every week there are 2 problem session class.
There are 3 sessions.
3, no? Okay, I am having so many problems, more problems. I get next time. So you'll be there, ma'am?
I'll be there on Fridays.
Right? So Friday. Friday. Today is Friday. Okay. So next class I'll be having so many problems for weekend also.
All of you watch lectures, I'll only prepare problems and I'll discuss.
And ma'am, my mathematics. And ma'am, last problem, ma'am, that I will solve. That was something look into. Okay, ma'am.
Yeah, that I'll look into it. I don't recollect that properly, so I'll look into it.
So should I mail you, ma'am? Can you please share your mail ID?
No, it's fine. I'll guided back propagation. No, I'll see.
Okay. So with 6 questions that will be.
Yeah, that's fine.
Okay. Thank you.
Okay.
Thanks.
Ma'am,
Yes.
on when I log in, I have access to only 5 questions. I have access to remaining questions, ma'am.
Where? No.
I cannot access to remaining questions, ma'am. When I log in, I have only 5 questions for assignment 7 non-repeating assignment, ma'am.
5 questions for assignment 7.
Non-repeating.
Can you post this on that discussion forum? I didn't really get what you were asking.
Can you put it, ma'am?
It's very noisy.
Actually, ma'am, he is telling that in ungraded assignment there are only 5 questions, but
Oh.
the sir was showing more than 10. That was my question also. Please share that.
Oh, the one which he was sharing right now.
Yeah.
He was sharing previous year's assignment questions, so which is different from yours.
Can you please share if you have?
Previous year's.
We are also students. We have to prepare for that.
Previous year session papers. Sure, I'll look into it and I'll share.
Okay, ma'am. Thank you.
Because that time registered students will have access to that. We'll have to check if I can get that. Yeah, but I'll check that and share. Okay then. Okay, thank you everyone.
Thank you, ma'am.
Bye.